Good evening, Doctor. I'm Vikneswary Sooriyanarayanan. My metric number 197748. Today, I'm going to present about liquid characteristics and dimension analysis. Okay. First of all, liquid characteristics. Liquids are almost incompressible, and also liquid molecules are pretty close to each other, but it's not very close. The molecule does not have space between them, but they have a little bit space, and the molecules cannot squeeze closer one another. Liquid have fixed volume but not a fixed shape. They have fixed volume, but they do not have fixed or definite shape. Liquids flow from higher to lower level. Liquids have their boiling points above the temperature and under normal conditions. The liquids on heating slowly changes to vapor or gaseous phase. This process is called as boiling. Dimensional analysis. Dimensional analysis is a powerful aspect of modeling and simulation. Characteristic quantities are formed by a combination of model parameters and give few insights without detailed analytic or numerical calculation. Dimensional requirements lead to Buckingham's pi theorem, a general mathematical structure of all models in physics. These aspects are illustrated with many examples of modeling, for example, an elastic beam on support, wave propagation on a liquid surface, and Lennard-Jones potential for the interaction between atoms, the Lindemann melting rule, and saturation phenomenon in electrical and thermal conditions. So we start with Rayleigh's method. Rayleigh's method is an alternative method also based on the fundamental principle of dimensional homogeneity of physical variable involved in a problem. The procedure starts with first step, which is the independent variable is identified and expressed as the product of all the independent variables raised to an unknown integer exponent. Second step, equation that indicates of n fundamental dimensions of the variables involved and n independent equations are obtained. And these n equations are solved to obtain dimensionless groups. The next, Buckingham's pi theorem method. Buckingham's pi theorem, also known as pi theorem, is used to determine the number of dimensional groups required to describe a phenomenon. According to this theorem, the number of dimensional groups to define a problem equals to total number of variables n, like density, viscosity, velocity, is all, minus the fundamental dimension p, like length, time. We can see this more in our example. We will use MLT procedure where, for example, we have a pressure drop. So the symbol is delta P, and the MLT that we're going to use is ML -1, T -2. For the pipeline, the symbol is L, small l, but the MLT symbol that we're going to use is L, the big L, capital L. Pipe diameter, the symbol is T, the MLT that we're going to use is capital L. Fluid velocity, the symbol is V, and the MLT we're using is LT -1. Fluid density, the symbol is rho, the MLT symbol we're using is ML -3. Fluid viscosity, micro, that we're using is ML -1 T1, and others. This is my first example for Buckingham's theory. The question is, a deep deflection delta of a cantilever beam is a function of a tip load W, beam length L, second moment of the area I, and Young's modulus E. Perform a dimensional analysis of this problem. Okay. For the first step that we should do is identify a relevant variables. Okay. According to this problem, the relevant variable that we need is delta W. Delta is a cantilever beam, function of tip load. Tip deflection, it's delta. W is tip load, L is beam length, and second moment of area is I, and Young's modulus is E. The next, we write down the dimensions. Okay, for delta, the dimension is L. For W, the dimension is MLT negative 2. For the length is L. For the I, which is I is the second moment area. The dimension is L square L power of 4, and E Young modulus. The dimension is M L negative 1 T power of negative 2. For the step 3, we establish the number of independent dimensions and non-dimensional group. As I explained before, how we going to number of independent, we will list down the relevant variables, list down the independent dimension, and then we will count the non-dimensional group where relevant variable minus the independent dimension, the answer is 3. Okay. For choose M equal to 2 dimensionally independent variable, for example mass or time independent. Then we create the pi theorem. Pi 1 delta per L is L per L. Pi 2 I per L4, which dimension is L4 per L4. And for pi 3 W per EL2, we substitute back what the dimension is. We have wrote down here, so we substitute back here. Then pi 1 is a function of pi 2 and pi 3. So here is how we're going to prove it. And there, so we got the answer is 1 over 3 W pi 3 EI. But when we include the pi, when we include the dimensional, and we will get the answer 1 per 1 over 3, 1. Okay, this 1 over 3 is showing the number of non-dimensional groups. Okay, next we go to the second problem that will solve the trailbacks method. Solve a pi problem is a general problem that how we're going to use. So from this we can know that, okay, from this the final answer can be used for any other number of the equation they have given. If the size, if they give the different size of number, different size of pipe diameter, we can use this equation to get the answer. So let's see how we're going to solve. So step 1, we wrote down the pipes problems equation where delta P per L is A V power of A, DH power B, rho power C, and micro power D. But A is a dimensionless constant. For step 2, we substitute back the dimensionless symbols. Okay, and step 3, okay, and then we can do the, okay, from this we can compare, right? Okay, for L, C plus D equal to 1. Here, C plus, for previously as we know, yeah, C plus D equal to 1. A plus B plus C, 3 minus D is equal to negative 2, and negative A minus D is equal to negative 2. From this, we can come out that A equals to 2 minus D, B equal to negative D minus 1, and C equal to 1 minus D. Overall, we can see the constant is only D here, which make our equation more simpler. Okay. Then we substitute back what we found here. and we can get the equation that changes in P per L is equal to AV2 rho dH in the bracket micro per VDHP rho D. As we know here, the constant now is only D, but previously there is a lot of constants, what are the power constants A, B, C, D. But now we only have one constant. So this is what we learn from the Buckingham's theory and also Rayleigh's theory. So that's all from me. Thank you, doctor, for giving me this opportunity and let me learn more and help me to increase my knowledge. Thank you.